Hi everyone. Promise, last lecture on strings. I thought I was going to combine both it together, but I actually broke it into two parts. I want to show you this in Visual Studio just to get a feel for things. I already have it running right now because there's a bunch of other text that we're going to go over when we do malloc and calloc and all this kind of stuff. But for the time being, let's look at what we have here. I'm going to make a string, a text. Notice the A for array, just to help me understand that it's an array. A text 2 for another array with the word hello. Notice they're not the same hellos. One's lowercase, one's uppercase. So I'm going to walk down a couple steps in here. Make sure that a text is equal to hello world. A text 2 is equal to hello. Great. What is the length? I'm now going to call string length. What is the length of this string? Well, if I look at this here, I would expect it to return 5. The 0 as at position 5. If I actually look at my array, I should see a 0 at position 5 right here. There we go. So this is our string length function in action. Not the one we wrote, but the one that's built in. Hey, it's equal to 5. So I'm going to print off that message saying that the string length is that. How about a string concatenation? I'm doing the safe version of string concatenation. It's saying it has to be at most 20 characters long, right? Because hello 2, text 2 is exactly 20 characters long. Okay, so I'm going to put this hello world onto this a text 2, provided that the whole thing is less than 20 characters long. That's actually an interesting problem that we may have. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 characters, 12, 13, 14, 15, 16. I'm still under 20 characters. I think that this will be the maximum number of characters this can be, not the maximum or size of this array. That is actually a potential issue that they have. I'm not sure exactly what string concatenation will do in this particular situation. I'd actually normally like to test that. So will it work when it's greater than 16? This is only 11 characters. Will I have an overrun otherwise? All right, so let's do one more step. Let's see what string concatenation is. Hello world. Great. That's what I expected it to. It concatenates or adds this at the end of this. That's what string concatenation does. And then I can figure out what the length of this thing here is, and it is 16. Now, if I made this 15, which is longer than this, but not as long as the full new string, I'm wondering what would happen. So, and then I can print off my hello world. Great. Here is me using string. I'm going to look for whoa in hello world. What I would expect is that it is when we're done, we're going to get a pointer. We're going to point to the W in world, and so the string will be world. That's what I expect to see here. We'll have to look at this on the output. And then after all of that, then I'm doing a comparison between a text and a text 2. See which one comes first. We'll look at a text and a text 2 string comparison very, very, very shortly. So let's look at this. The message is a substring whoa is at world, right? It is the pointer is it's pointing to the where the WO is in my original string. So it's further down in my main string. The string comparison, however, is going to compare hello world with hello world over here and hello world. But one's capital and one's lowercase. So which one's going to come first? What's going to happen there? So let's have a look. A text comes before a text 2, and we're going to get a true or a false here. So what do we get? It's going to be an integer really, but a text substring WO is at world 2. Okay, a text comes before a text 2. True. So a text is going to be before a text 2. The lowercase h is it's going to return a value of 1. Okay, we're going to see this in action a bit more. I want to close this off. I'm going to run my program again. I want to see what happens with this. So let's make it 15 and see if it blows up in my face. I'm curious. All right, 1BC. Like an array of size 40. Okay, there we go. Now we're at the part that I wanted to look at. So what happens if I do string concatenation with size 15, but the array size is greater than 15? Oh, there we go. An assertion fails. At least it caught that, but I'm not sure if it's due to, let's try retry, and let's have a look at this. No, that's just a going outside, looks like it's just going outside of the array bounds. Oh no, I think string concatenation must be doing this. It doesn't just go outside the array bounds. This is why we have the underscore s. If I try and make a string that's too long, it yells at me. Great. That's actually at least somewhat useful to know. He won't merely let me keep on putting things in my array, even if I don't have space for it. All right, let's look at what we've been looking at. So we had comparing strings. Okay, we had string class and string comparison. Okay, we're going to look at a couple more of these, and then we'll stop. So last time we were looking at, there's a 0 at the end of our string. We had some predefined functions like string and string length, and then we actually just looked at this in code. The reason we had to look at binary and hex was because we need to know what's going on with characters, and we need to be able to look at these characters and see and be able to do some things like converting it to uppercase to lowercase. And you only know that if you know how hex works, and you get these weird situations where you need to be able to see the actual raw data. So how about comparing two strings? If I have two strings here, str1 and str2, I can compare the two strings, and much like if I'm trying to organize books alphabetically, or anything alphabetically for that matter, what I do is I take the two words that I'm going to compare, like your names, for example, if I'm sorting out your exams. I check the first character of each of your names. If I'm sorting out between two, figuring out which of the two names comes before the other one. I take the first character for both names, check it. Are they the same? If they are different, one goes before the other one, right? The character that comes first in the alphabet goes before the second one. If they're the same character, I go to the next character, and then the next character, all the way down. How I would do normal alphabetical ordering, right? If one name is Smith and the other one is Smith with an E at the end, Smythe, then Smith or Smythe with an E at the end comes after Smith. It has an extra character at the end. This is how we normally sort things alphabetically. Well, string compare does that. If they're identical strings like hello and hello, it will give me the value 0, as in they're identical. It gives me -1. It means that the first one has a smaller ASCII value. It comes first in the alphabet in terms of ASCII values than the second. That does mean that capitals will come before lowercase. Something to think about. So if it's a -1, it means A comes before the Z. Fine. If I get a 1, so I need to have three different values. I need to have, they're identical. The first one comes for the first string is smaller, second string is smaller, right? With three different options. And so if I'm comparing hello to hello, this should come first alphabetically, and so I'll get a 1. If I go back to my code, you'll see that the capital hello comes before the lowercase hello, and that's why text 2 comes first. Okay, this allows me to just compare two strings. It's a very, very useful function in that respect, but you need to know that it's comparing the ASCII values from one to the other, character by character as it walks down. Okay, we also have numeric conversions, so I can convert from an ASCII character to an integer. So you give me the character string 1, 2, 3, 4, and it will give me the number 1, 2, 3, 4. That's what A2I does. A2L gives me a longer precision version of A2I. A2F gives me a double value. So it's 3.14. This thing, if I give the string 3.14, it will give me the double value 3.14, the numeric value 3.14. And then there's the final other way around. So in each of those cases, this is where we have inconsistency. If at any point in time you give me something that is not a number, let's say you give me call A2I with the number A or hello. That's not a number. I know, sorry to disappoint. Or 1A is not a number. Some of the times it gives you an error. Some of the times it'll just give you the number 1. The very first, the number until you hit something that's not a number. Depends on the system. So these are actually very inconsistent. In fact, what they're doing is they're supposedly under the hood, they're using, printf, sprintf, and fprintf all call these functions down here to actually do this conversion from an integer to a string. When we do that %d, it's actually calling a2i, a2l, a2f, one of these functions. We also have another way of converting from an integer to an ASCII string. And so what we end up getting is we put in a number, we have the string, the character buffer that we're going to put things in, and the third parameter is the base that we're going to convert to. That's a weird thing, but hopefully we'll have an example of it. So a2i for 1, 2, 3, 4 gives me the numeric value 1, 2, 3, 4. A2L for 5, 6, 7, 8 gives the numeric value 5, 6, 7, 8. A2F of 35.7 is 35.7. This I2A, integer to ASCII, with the value 2322, let's say, or 1, 2, 3, 4, 5, 6, whatever the case is. Let's say 23222. It will put in this character array, of size 10. It will put 2322, but only if it's base 10. If I put an 8 here, it doesn't actually put in. For base 8, it puts in 1, 2, 3, 4, 1, 0. The base 8 version of 2322. Oh my god. So yes, it can actually do some base 10, base 16. It can convert your bases on you. You would normally need to I think you can leave it off, but if I put in an 8, it gives me a base 8 version of that string. If I put in a 10, it would give me 1, 2, 3, 4 when I put that in. Let me see here. Oh, sorry. If I put in 1, 2, 3, 4, 1, 0 for base 8, and I say it's base 8, the base 8 string value is 2322. If I put in base 10, it'll be 1, 2, 3, 4, 1, 0, I guess. There's going to be the other characters as well. Let me see here. Should give me that string. Right. This is just, it's going to convert it. I can even say base 2 and it'll give me a binary number. You could use I2A to convert from integer to binary without having to do anything at all. Without having to do all the fancy stuff we were doing in other assignments. C strings contain non-digits, are undefined. So as I said, when we convert I2A, there's no bounds checking. So first of all, I2A, there's no bounds checking. So if I run out of space in my array, bad things happen. So if my array is size 10 and my array is size 10 and the number I have is 11 digits long, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, it's going to go outside of their bounds and I'm just going to have some random weird crap happening. It's undefined. There's no bounds checking at all. So you need to make sure that the number you're putting in there, you have space in your array. Yes, you have to do it by hand. For C strings to go the other way around, from A to I, it will take in a number and sometimes it'll stop when it gets to the first non-digit. Sometimes it just returns 0. Depends on the mood, it depends on the weather, it depends on the operating system. And so therefore you cannot assume kind of consistent behavior. It is a pain when it comes to these kinds of conversions. So you have to just be aware of it. Okay, coming soon, we're going to be looking at file.io. I just wanted to preamble things. This is, I'm going to make a file. It's a pointer to a file structure called I'm going to call it pfile. I call fopen, file open. I pass in the pointer to the file, and then I put in the string name. This is where strings come in. And I say if it's a read only or it's write, for W for write, right? If I can read to the file, I can write to the file, right? And it allows me to open a file and read from the file. We'll be getting to that soon, just in case it comes up in the labs. This is how I do a file open. And then afterwards, what I need to do is check to see if this file pointer is pointing to null or not. If it's something that's a legitimate value, it means I can now pull things from the file. Okay, That's just a preamble. We're going to actually get into much more detail with this later on. And then finally, the BIT1400 preview. We talked about C strings being hello world. We have this 0 at the end. And then we have these functions, these functions that I could call to help me with my strings, like str, string. Well, the string objects, so here's what we had before. String objects do things a little bit different. I will make a data type called string with the word hello world, and it will, so I would need to include the string libraries in there. And I could just make a string, I could add to a string, I can do all sorts of things. What's weird about the string class is I don't have to worry about running out of space, and this is what we're going to be dealing with in BIT1400. All strings have methods associated with them, meaning an object in C++ is bundling together a data structure or an array, the kind of data that we're dealing with, and a bunch of methods. So I can say, hey, movie title, what is your length? And so movie title dot length will give me the length of that particular string. Instead of calling strlen, I say, hey, movie title, what is your length? The string itself knows how to evaluate things. It knows how to compare two strings. It knows how to calculate the length of its own string. That's what we're going to be doing with objects later on. We are not doing it this term in this class. So this not on the exam. I just wanted to point out there are weird things when it comes to strings. More importantly, when I make a string, not only do I have this array of stuff that I have for like the movie title, but I have other variables. I have a size, I have a capacity, and I have a whole slew of methods that also go along for the ride. Every single object encapsulates all my methods and all my variables, which is kind of weird. Okay, which string should I use? You're using the C string. Just stick with it, get practice doing it. Do not put in a normal string on the exam. Do not put a string object anywhere in this course. We will look at them later on. So, only C strings. You should be able to use both eventually, so make sure you can use C strings now. Okay, so we're not going to even look at this, but here's me calling the append function associated with the movie title object, and I can call the append function on the movie title object. That's what we're doing when it comes to string functions. When we come back next time around, we are going to be looking at pointers and memory, and it's a whole brave new world of all the crazy things you can do with that. There's a lot of stupid things you can do with pointers and memory. So buckle up, because it's going to be fun. All right. Thanks, everyone.